Hi, this is Mariyani-Squire, and I'm recording this video for two reasons. One, to see whether the equipment works in this room and what kind of quality it produces, and also to provide a little bit of background on a paper that I'm thinking about at the moment, or rethinking at the moment, about the problem of induction. So the problem of induction is sometimes characterized by the question of how do we justify the claim to know about the future based on our experience of the past, or based on our limited experience in the present. Empiricists try to answer this question by saying, well, there are laws of nature and they are just brute facts about the world. Certain things occur in regular relation to each other, and that's the end of the story. That's how we are able to infer from the past or the present and the future into the future. So the Humean problem with this, from David Hume, is that this itself seems to involve a circularity, because in order to how do we establish that there are these laws of nature, these universal laws of nature, or this uniformity to nature? Well, we presumably acquire that knowledge by inductive inference. So what we're doing is we're making an inductive inference to the future based on laws of nature, which themselves are based on inductive inferences into the future. So we've really got a circularity here. This is our problem of induction. This is David Hume's problem of induction. He says there's no real solution to that. He doesn't see a way around that problem. There's no real justification for making an inference from particular instances now or in the past to all time. So recently, and by recently I mean from the mid-1970s onwards, there's been a growing movement in philosophy towards a more robust ontology. And this is embodied in what, let's call it, an essentialist, realist ontology, which basically says that there are things in the world, and those things have certain essential structures to them, and those essential structures give those things certain causal powers or certain causal dispositions. And so once we've figured out what the structure, the essential structure of a thing is, say it's diamonds or glass or copper or whatever, fundamental particles of nature, then once we figure that out, once we know what they are, then we can make inferences from our observations of them now into the future. So once we've discovered that glass breaks if a glass pane breaks if you throw a brick at it, then we can safely infer that in the future the panes of glass will break if you throw bricks through them. Why? Because of their essential nature. Okay, so this appears to solve the problem of induction. It's a way of trying to solve the problem of induction. The question is, how do we justify, and it's that ontology is really an elaborate and sophisticated version of the uniformity of nature principle, that nature is uniform in some way, and that enables us to make inferences in the future. Okay, so our question then is, how do we justify this realist ontology? Why should we believe it's true? So what we want to try and avoid is Hume's problem of using inductive inferences to conclude that the world is as it is, because then we'd be relying on induction to establish the validity or the workability of induction. So we'd be trapped in a circular argument again. So what we need to do is we need a different approach. So in 1975, Roy Bhaskar wrote a book, The Realist Theory of Science, in which he put forward an argument for believing in this realist ontology. And he put forward not an argument from induction, but an argument in the form of what he called a transcendental deduction. Basically, this means that you're trying to rigorously answer the question, what must the world be like? What must the world necessarily be like in order for the scientific practices that we know about, say, for example, experimentation, to be intelligible? How can we make sense of the act of scientific experimentation and then the application of the discoveries in experiments outside of the experimental setup? How can we make sense of that? What must the world be like in order for that to be the case? All right, so the answer that he comes up with is, surprise, surprise, the essentialist ontology. Fine. My question, that's the background. So my paper is trying to figure out whether that transcendental deduction really does solve the problem of induction. On the face of it, it seems to. But once we dig into this transcendental deduction, I think it might be the case that either the deduction is invalid, in which case it doesn't provide a justification for the underlying uniformity of nature, which is the basis for solving the problem of induction, or the transcendental deduction is actually circular, in the sense that it has to build into its premises the conclusions that it comes to. And that obviously is not a satisfactory justification either. And if that's true, then we don't really have a firm justification for this isn't a firm justification for the essentialist ontology, which is the basis for the uniformity of nature, which in turn is the basis for solving the problem of induction. Just as a side note, something that I won't really go into the paper, but is kind of interesting, is to try and think of solving or dissolving the problem of induction in a different way. I think one of the things that both the empiricists and the essentialists, the realist essentialists, have in common is that they take the uniformity of nature principle to be a factual claim. And it's a factual claim that requires justification in order to move on with doing science. And I think that's wrong. I suspect that's wrong. And the way to get around it is to go back to it's an old response to this problem that comes from the beginning of the 20th century, and it's the first half of the 20th century. And these days it's very old hat and poo-pooed as totally unsatisfactory, and I sympathise. But this other way of responding to it is to say, well, let's not think about the uniformity of nature principle. Let's not think about it as a factual claim. Obviously, we can say it's either true or false. But how does it function in science? In science, are scientists, when they're formulating their theories about particular phenomena, whether it's economic phenomena or geological phenomena or chemical phenomena or whatever, and when they're engaging in experimentation, And when they're doing statistical analyses of the phenomena that they're interested in, are they trying to establish that the uniformity of nature is a fact? Or do they worry that it first needs to be established that it is a true fact? I don't think they are. I think it's just a presupposition that scientists hold. It's the basis for doing science. I mean, if you didn't believe in the uniformity of nature, you wouldn't waste your time doing science, because you wouldn't think there was any reason to believe that the world would pop out of existence tomorrow, or would turn into a giant bowl of spaghetti or whatever. No scientist believes that the world is just a chaotic cosmic set of coincidences which could all, turn to mush in any given second. They believe that there's uniformity in nature, or they presuppose it. And it's based on that presupposition that you go about doing your formulating particular theoretical propositions, and engaging in experimentation, and engaging in other kinds of empirical investigations. The uniformity of nature principle functions as a kind of rule, or as a kind of imperative about how to conduct your particular theoretical and empirical work. It's not really a factual claim which is up for question. And if that's the case, then there's no real, in the kind of grand metaphysical sense, there's no real problem of induction to solve. You just presuppose that it's the case. I mean, you can make inductive inferences. I don't think any scientist really believes that their inductive inferences are absolutely rock solid and guaranteed to be true. No one believes that. But they attempt to, with the limited information that's available to them, make projections into the future. And insofar as those projections turn out to be successful, people continue to believe them. And insofar as they start to fail, they tend to stop believing them, unless they're total dogmatists, and they can believe it for a little while. And eventually, at some point, I mean, we don't need to have rules about when, they should give up those dogmatic beliefs. And if they don't, then we start thinking that maybe they're not really scientists, and they might be some kind of, idiot. Anyway, that'll